All right. Let's go ahead and go over Chapter 3. Hopefully Chapter 3 is going to be straightforward, and then I'm going to go through another example of basically objects of objects. Basically, you have an object and you compose it of other objects to try and really solidify how we organize objects in general. So yeah, they call it advanced object-oriented concepts. I really think it's pretty basic, but that's okay. So constructors, I think we've touched base on this. What was the special case of a constructor? I'm going to jump over. I'm going to go and create a new Java class. I'll call it student. So what was the constructor in Java?
They're the same name as your class.
Yeah, so public, well, it doesn't actually have to be public, but it has the same name of your class. And it doesn't have a void or return. So this is a empty constructor. Empty constructor is usually not too helpful, but we'll leave it there. If we were to design an object to represent a student, what would that object need?
Things a student would have.
Which would be?
Like student ID.
Student ID, okay. Private int MID. Yeah, we'll just make it easy and call it private name. We're not going to do last name, first name, because that's just going to get too complicated. So ID, what else would we need?
GPA.
GPA? Okay. All right, we could do GPA.
What year they are? What's that? Word for that?
Graduation year?
Yeah, that. I was just going to see if they were senior or something. Like,
Oh, what is that called? What year they are?
yes, I like that.
And not called their class.
Class.
GPA rather than GPS.
Class. Level.
GPS. You gotta have the
Guys know where
GPS.
they're at.
I called it GPS. Gotta have that GPS. There's no other way around it. What else might they have? Age. Age, okay, cool.
Male or female?
All right, so sex.
Yeah. One of two. One of two genders.
Although I guess I should say gender now. Whatever.
No, one of two genders.
Anything else?
I'm a gender fluid.
We're gonna just let that one go for now.
I change as I
Language.
please. When I decide I want to move on to
Race.
Let it go. What was another idea?
Race.
Race. Okay. Fortunately, we have to record that for government purposes.
Yep.
That's terrible.
Anything else? Well, I'm sure a lot of people believe it's necessary.
Man, it's unnecessary evil.
Evil.
No, just an evil.
We probably want to get
All American here.
academic history
Hopefully.
and current schedule. So I'm just going to put those as comments for now. We're just going to simplify a student to just have an idea and a name.
Isn't it like when you apply here, they ask you, like, have you ever gotten, like, a felony or, like, any criminal history?
Oh, yeah,
They
that's
ask
right.
you your religion as well.
Well,
Oh, wow.
because
I
it is
know
a
that.
rhythm, you know.
You can choose not to
The
answer.
courses are based on
What?
The religion. So religion and criminal history.
Yeah.
Nobody needs to know that.
All right.
I think that's more important than race, to be honest.
Criminal history and religion. Yeah. Well, we're going to let the system is what it is. All right, empty constructor. So the empty constructor is not too useful, but if we were to, let's see. Let's go create a new Java class. I'm just going to call it main. And this is just going to be a class where we can just fiddle around with some code just to see what happens. So here we could create a student. Good old Bob equals new student. Morning. Are you in applied networking as well? Yeah, well, welcome. Good morning. Well, we create a Bob. Well, we create a student, as I should say, what this is really doing is it creates an identifier called Bob that's going to point to a student object on the stack, and then we're going to create a new student object on the heap and return a pointer to and store a pointer to that object in Bob. Can anyone tell me what's actually wrong with this code? Not from a syntax perspective, because I can run and this code is going to run just fine. But semantically, what's wrong with this? Let me ask a very detailed question. What's Bob's name right now?
Bob? No.
No.
Yes, their name.
Yeah, we haven't done a name. So if I go back to student and I do a what was it? Public string get name, return m name. Go back over here. We do student.out.println bob.get name, and I'm going to go ahead and run main. Null. Well, that's not useful.
His name is null.
His name is null.
It's void.
I was told you might need that.
It's void.
Wow.
I would totally name a kid on Noel.
So we probably don't want to allow this to happen. We want to enforce that if you create a student object, you want them to at least have a name and an ID. We should probably enforce that somehow. So the way we do that is we disallow the empty constructor. How could we disallow the empty constructor? I've highlighted it to give you a significant hint. Private. So if I made it private, save that, go back over to main, student has private access. You can't access this anymore. So not going to allow me to do it, not going to compile. But you know, we do want to have a way to create a student. So maybe we should actually give it a public constructor. And we've decided that every student needs to have an ID and a name. So let's go ahead and pass string name and int ID. And that way I can actually set my name equal to name and then my ID equal to the ID. Now go and comment this. Constructor passing in name and ID. So now, if I jump over here to main, not allowed, but I'll go and comment this out, copy, paste. But if I pass in the name, Bob, and what should his ID be? 1, 2, 3, 4, the best ID ever? Oh look, I accepted that. So now if I run main, it's now Bob. Hey look, he actually has a name. Alright, so I went over that, what that's doing. I explained briefly why. Can you tell me why we want to do it this way?
So that it will always have an answer, not a null.
So it will always have a name and an ID. So OOP here is actually giving you a tool to enforce that an object has to have certain characteristics for it to exist. So you can, in a way, guarantee an object will at least be able to do something by basically enforcing certain mechanisms. In this way, forcing that the constructor, the empty constructor, cannot be called. If you're going to create a student, you have to give me at least a name and an ID. We'll go over and jump over to student. And so I have a get name. Obviously, I should probably have an int on a get ID. Return MID. Return with an N. And so down here I can do get name, and then afterwards I can do get ID. Save that, run it. Bob and 1, 2, 3, 4. Passed in via the constructor. Any questions on this, or why I'm doing it this way? Jump back to the student. Why am I making the name and the ID private? Might be a little hard to see at first, so we'll get to that a little later. Okay, so constructor, methods that share the same name as a class, good. Constructor is called when a new instance of the class is created. An example here is right here. Bob, and let me break this out so it's a little clear. Creates a variable called Bob that points to an object of type student. Okay, that's all this line is doing. Creates a variable called Bob that points to an object of type student. It does not create the object. The object has not been created on that line. Okay? Let me make that clear. Object has not been created. Here, create an object of type student, passing in Bob and 1, 2, 3, 4. Set the variable Bob to point to that object. Okay? And this next line is where you actually create the student object, passing in Bob and 1, 2, 3, 4, and then you're copying a pointer to that object inside of the variable Bob. So Bob now points to the student object created with these parameters. Is that clear? Somewhat murky, crazy. All right. What's inside a constructor? Basically anything to create an object to initial, stable, safe state. For a student object, that's not too important, except for that we enforced that you have to give me a name and an ID. Of course, we could validate that the name and the ID are something useful, but we're just saying that you have to give me something. Default constructor. You don't actually have to write a default constructor. If you don't write a default constructor, a public one is provided by default. It's default, but it will be public. So if you want to make it private, you actually have to explicitly make it private. You can have multiple constructors, so there's more than one way to create this student object. This one's being passed a name and an ID. What could another constructor look like for student?
You could just have other elements that they need, like GPA or class level.
Okay. Oh, sure. Yeah, so it could pass in the GPA or class level. So this constructor, did y'all do, what was it called? Function overloading in C++?
That was over the storm, so.
Oh.
We had to like learn it ourselves.
Okay. Okay, so function overloading is when you have a function of the same name, but you're declaring different functions dependent on the type. So, this is one function. Notice I could make another one down here. Maybe it's only past the name. Then you have mname equal the name, and then we'll have mid equal to -1. Notice that there's two functions called student here. One's being passed a name and an ID. The other one's being passed a name. You're overloading the function with two different versions. You could call either. So if I was over here in main, I had Bob equal to that one, and maybe we'll have student Alice equal to new, student Alice. So that's going to create another student using the other, let me spell Alice correctly, the other constructor. And if I do system.out.println alice.getName, probably print her name out. And then if I do get ID on Alice, quick, who's been watching? What should it print out for her ID? -1, because it's calling this function down here. So let's go run it just to make sure it does behave the way we want it to, and there you go. Bob, 1, 2, 3, 4, Alice, -1. So you can have multiple constructors just like you can overload methods in C++. You can overload all the methods inside of Java that you want to. Right, the signature of the method has to be different each time, consists of a method name and a parameter list. In other words, if you have this function here, you cannot just copy, paste, and type code here, because Java doesn't know which one to use. It's already been defined. So in order to overload a function, it has to have a different name. I mean, a different parameter list, sorry. Same name, different parameter list. Okay. Superclass. Ooh. When using inheritance, we haven't talked about inheritance yet, and we're going to next class. I'm going to skip that. And then error handling. We'll talk about that. We'll get to a lot more about error handling later on. But assume your code has the capability to detect and trap an error condition. You can handle the error in several ways. You can try and ignore the problem. Your code's going to probably fail. Check for potential problems, abort the program when you find it. Not a bad thing. You can try and catch the mistake and attempt to fix the problem. We did option 3. Excuse me, option 3. What did I do? Passed in a name but not an ID. What did I set the ID to? -1. And we're just saying -1 is not a valid ID, so if you ever see -1, you know, hey look, we don't know what their ID is. So this is a mistake, so to speak, but we have at least attempted to correct it or show the user, hey look, something wrong is going on. Or throw an exception, and this is actually the preferred Java way of doing it. Throw an exception. It's beyond the scope right now, so we're not going to do it. And that should concept of scope. Okay. As I said, multiple objects can be instantiated. So we have Bob up here and Alice down here. These are two objects both instantiated from the student class. But there's something called scope of the variables. We can't, if I'm down here and I try to do system.out.println Alice.name. Oh, come on. There. Stay. Okay, there we go. Name has private access. It's not in my scope. I'm not allowed to access that variable because I'm in a different class, namely main. So I don't have access. It's beyond my scope. Local object class. We'll get to that. That's not too. Okay. Let's see. Do we have any example here? No, we do not. So if you're creating a function over here, say we're using main, int, I don't know, value equals 1, 2, 3. The scope of value. Let me back up. Did you talk about scope in C++ much? The scope of variable. Do you talk about lifetime of a variable when you have access to a variable? Okay. So let's do a quick scoping exercise. Public int, I don't know, sum, int n. Int sum for int I equals 0, I is less than n, I plus plus, sum plus equals I. And we'll have sum start off at 0, return sum. Okay. And if I go down here, system.out.println, sum, let me change the function name to something else. How about take sum? Take the sum. There we go. Public static int. Take the sum to 100. For those you don't know, I'm going to take the sum from 1 to 100, sum it all up. Okay, I'm actually doing 0, but that's irrelevant. And then I'm returning what that sum is. I'm going to go ahead and run this real quick just to show you. Great. So if I'm in here, do I have access to the sum variable of take the sum? Can I access this variable down here from inside main?
No.
No. Why not?
Because it's below it.
Not because it's below it.
It's not in scope.
It's not in scope. I could take this function and move it above main, but I'd still have access to it. No, sum is not in scope. So this is called book calls it local scope. But that what's saying is this scope variable sum is only available in the take the sum function. Why is that?
Because that's where you declared it.
That's where you declare it, and when you were using the memory, remember I was talking about static, stack, and heap? That variable is declared on the stack. So once that function is allocated, that variable exists, and once you exit the function, it's deallocated. You no longer have access to it. It's also, that's talking about lifetime. It's also out of scope. Let me do public static void some other function. Running out of names. Double D equals, or we'll call it pi, 3.14159. And just for sake of argument, I'll just print out some other function. There we go. Oh, that's right. It doesn't return anything, so I'm just going to call it. Just calling it. There we go. Some other function. It's not going to print anything because nothing happens in some other function. But does take the sum have access to pi from this variable?
Yeah, because it's static.
The function's static, but is the variable static? No. So I do not have access to pi of some other function. Now here, do I have access to sum of take the sum? Can I access sum from take the sum? That's above me. Anyone? Any takers on no?
Can you go up some, take this,
Do I have access to sum of take the sum? AKA, do I have access to this variable right here?
Yeah.
In Java, I do not. While it does exist on the stack, because take some other function is called inside of take the sum, I'm now jumping out of the scope of take the sum. I now have a new scope for my function. So I no longer have access to that previous variable. Even though it's alive on the stack, I don't have access to it because it's in a different scope.
So functions can't call functions?
Functions can call their functions, like right
They call
here.
variables.
Take the sum is calling some other function. but functions don't have access to other functions' local variables. That's what's going
So
on.
it's called everything but the variables.
Right. Everything but the variables inside of it, because they're local variables local to the function.
Yeah.
So if you were to put the variable in like your main, and then you called it in take the sum, but then you wanted to refer it to some other function, would some other function use the take the sum answer? Or would it use the original variable?
Sorry, I didn't follow you.
I'll figure it out.
But what I think you're trying to get at, no, hold on, it is out of scope. Let me answer that. If I were to be in here and go public static int, I don't know, I'll call it count. I'll set it equal to 0. This is a static member of main. Will these other functions have access to count? Yes. Why?
It's a global variable.
It's global to the class. So any function inside the class has access to count. So I could do count plus plus here, and I could do count plus plus right here. And then when I'm finished with this, I can try and do system.out.println count, and it should give me, what is it going to give me?
So it'll do both of them, and then return the answer after it's gone through both functions.
Well, remember, count is a variable global to the main class. So it starts off at 0 because I made it static. It's incremented in take the sum, and it's incremented in some other function. So here I'm calling take the sum, which implicitly also calls some other function. So what should count be when it returns? I think I heard someone say it. 2? Yeah, it should be 2. Because I start count is 0 right here. When I go into take the sum, it starts executing, calls some other function. Then it jumps down to some other function, increments count right here, pops back, increments count again, return the sum, prints off the return right here in this print line, and then I print out count down here, which is currently holding 2. Sorry if you didn't go through scoping. But it's important to understand what's persisting and what's not. Because basically the local scope of sum is not persisting out of the function call because it goes away and comes back. But count is persisting throughout the entire class. All right. So that might have been a bit of a jump. Any questions on that? No? All right. Local object attributes. So here we go. Like I mentioned before, hey, look, they use count as well. It's a popular one. So in count, I think they didn't call it static here, but it's available to method 1 and 2 because the scope of count is for the entire class, aka from the beginning of that curly bracket to that curly bracket. So any function in here has access to count. All right. Class attributes. Let's see. It's possible for 2 or more objects to share an attribute by making it static. Ooh. Don't want to really talk about static right now. Well, yeah, I don't want to talk about static. Let me think of something here. We will talk about static. I got to come up with a good example for y'all, otherwise static will not make sense. All right, I'm going to create a static variable in here. The thing about static is there can be only one. So while there can be multiple student objects, there is only one static variable. And it's shared amongst all the student objects. For example, if I wanted to keep track of how many students have been created, I could do private int student count, and I'll set that equal to 0, and I'll put the word static in front of it. So student count, let me start with an S to stick with my naming scheme, because S is going to signify that it's static. That way it's clear when you read in code. is going to start off at 0, and you initialize it usually where you write it because there's only one initialization point for it, and that's when you declare it. So if I want to get the count, keep track of it, if I create a student with this constructor, I want to go s student count plus plus. If I create another, student with the other function, I also want to increment the count. So no matter which constructor you call, I'm going to increment the count. We also want to have a method in order to get it, so we'll do public int get student count, return s student count. So if I go over here with our code, we create Bob, we create Alice, and then I ask system.out.println, we'll do alice.get student count. What should it be? 2. I can also call it Bob. What's it going to be? Ooh, it's going to be 1 or 2. The objects are sharing the same variable. 2. When it's static, they all share the same variable. When they're not static, they have their own variables. We'll go ahead and run this. So it's 2 and 2. So static, there is only 1. This variable is shared amongst all objects of type student. There we go. Okay, there is only 1. Any questions about static for variables? What do you think a static function is? Let me ask this differently. If there's only one variable shared amongst all students, do you have to have any student objects for that variable to exist? No. So that variable is essentially global. It exists if you have 0 students or 100 students. That one variable exists. How about a static function? It's a global function. Again, it exists whether you have a student object or not. So I'm going to jump down and change student count from just a regular one to a static function. I go over to main. I can still call get student on these two. Watch, I'm going to run it, and Java is going to be completely okay with that. But what I want to show you, and this is the tricky part, I can do the class name dot get student count to also call it. Since it's a static function, I don't need the object, I just need the class in order to call the function. That way I never have to actually instantiate a new student object. So I run it, and again it prints out 2. Alright, be very careful with this, because can I do student.getName? Why can't I do that?
It's not static.
It's not a static function, but more specifically,
There's more than one student object.
there's more than one student object. There can be more than one student object. The function is tied to an object. You have to have an object in order to call that function, because it's not static. Okay. Everyone good with that? Any questions on that one? All right. Not allowed since get name must be associated with an object. All right. And the reason for that is get name's returning the name, so you actually need to know what the name of that particular object is. So there has to be more than one name variable, or namely one for each object. Okay. All right. Class attributes, operator overloading. We can't do that in Java, so we're going to skip that. Multiple inheritance, we're going to talk about inheritance later. Object operations. We're going to get to that later. Good. Okay. Any questions on what I've covered so far? All right, before I conclude this, I want to change this. Since I did a lot more in main than I thought I would, I'm going to refactor main. I'm going to change it to student main. Let's see. Refactor, rename to student main. That way we can have a main function, a later class called main. So student main, the old main class has now been renamed to student main. That's all I did. All right. How are we doing on time? Good. Let me go ahead and stop here.